Hi friends, welcome to Unacademy. Welcome to the YouTube channel. Students, as you all know, Unacademy offers plus courses for Karnataka CET students. Students who want to write CET exam in the year 2021 can subscribe the plus courses. So there are different plans, students, under Unacademy. You have a 12-month plan at the rate of 12,375. We also have a 6-month plan at the rate of 10,125. So whichever plan is appropriate for you, you can join. But whenever you join, kindly make use of this code Bhavani Live. Make use of the code and get the maximum discount. Students, we have different batches. We have a comprehensive batch, we have a Kannada batch, and we also have the champions batch. Now the different combinations are also available like PCM, PCMB, PCB. So you can enroll your name for any one of these batches. You can also take as many as practice tests. Before you face the real exam, you can take these practice tests, free practice tests. Students, whenever you opt for plus courses, both class 11 and class 12 topics will be done. All the topics will be done in detail. You will be given all the tips, tricks, necessary tips, tricks, previous year question paper, daily practice paper, full length mock test, all this with analysis. So kindly see to it that you will be joining any one of these batch. And for single subscription student, you have unlimited access. And not only that, in case if you haven't watched my YouTube channel, kindly watch my previous classes. And whenever you like, kindly do not forget to press the like button, like, share and subscribe. And also do not forget to subscribe the YouTube channel also. So we have been doing mock tests on solid state from the past few days. So let us continue with the same topic, the solid state. So I hope all of you are ready for one more mock test on the topic solid state. So all those students who have joined, welcome students, welcome to the class. So you can just see the question on the screen. Question number 1. The correct statement regarding defects in crystalline solid is. Now what is the correct statement? You have to pick the right one. Option A. Frankel defects decreases the density of a crystalline solid. Option B. Frankel defect is a dislocation defect. Option C. Frankel defect is found in halides of alkali metal. Option D. Schottky defects have no effect on the density of crystalline solid. So students, which one is the correct statement? So we will go for option 1. Frankel defect decreases the density of a crystalline solid. If you can see here, the first defect is a Schottky defect. In Schottky defect, the cation, you can see the cation, this one, the cation and the anions are missing from their lattice site. So the density will decrease. Whereas in a Frankel defect, the cation is dislocated from its normal position and moved to the interstitial site. So point number 1, that Frankel defect decreases the density is not a right statement because the particle which has been missed is in the interstitial site. It is not permanently missed from the lattice, isn't it? So first one is not a correct statement. Frankel defect is a dislocation defect. Of course, isn't it? The smaller ion, the smaller cation is dislocated from its original position. So this should be a correct statement. So option B is a correct statement. But then we will check whether options C and D are also correct. Option C. Frankel defect is found in halides of alkali metal. Now Frankel defect, if you can see the Frankel defect here, Frankel defect is seen when the size of the cation is very much smaller compared to the size of anion. Or in other words, there should be a greater, size difference between the cation and the anion. And it is seen in zinc sulfide, silver chloride, not in alkali halides, metal halides. Like sodium chloride, you don't see in sodium, you see in zinc sulfide, silver chloride. So this is also a wrong statement. Schottky defect have no effect on the density. It's not possible. Because in Schottky defect, the cation and the anions are missing, student. Missing from the lattice side. That means there is a decrease in the density. So the only possible answer would be option B. Frankel defect is a dislocation defect. Okay, so we'll go to the next question. Read the question, students. If A is the length of the side of a cube, the distance between the body-centered atom and one corner atom of the cube. So the side of the tube, the length, the edge length of a cube is given as A. And the question is, you have to find out the distance between body-centered atom and the corner atom. So there are 4 options which are given. So students, in case if you have an answer, you can write it, in the comment box. You can give the answer. What is the right answer, students? Okay. And now look here. If you take a cube, now this is a body diagonal, isn't it? This is a body diagonal. And we know the body diagonal of the cube is root 3 into A. Root 3 into A. This is the body diagonal of a cube. The question asked here is the distance between the body centered atom. Students, you see here, you will have an atom here, right? You will have an atom here. If I'm 1 minute, let me show here. Okay. So from here to here, it's a body-centered cubic lattice. So you have a particle here. You have a particle at the center, isn't it? And you have a particle like this. Or in other words, let me show it clearly like this. You can see. Now, the distance from the body-centered atom, this is the one, central atom. This is body-centered atom, to the corner atom. So, the question is asked from here to here. The distance between the body-centered atom and one of the corner atom. The body-centered atom and one of the corner atom. So we will, you need to find out. Student, this length is root 3A. This body diagonal is root 3A. Now the distance between the body-centered atom from here to here to the corner atom is asked. That means it is root 3A by 2. Half of it, half of the body diagonal, so it will be root 3A by 2. So answer will be, student, option D, root 3A by 2. I hope you have understood. Okay. So we'll go for the next one, next question. So students, are you ready? The number of carbon atoms per unit cell of diamond. See, question is asked, in diamond, how many carbon atoms are present? In one unit cell of diamond, how many carbon atoms are present? Now we all know that a diamond is made of carbon atom, isn't it? Students, diamond has a structure, or diamond is like, I can say, zinc blend structure. Zinc blend. Zinc sulfide. So diamond is like zinc blend, okay, zinc sulfide. Now here in this case, if you can see, if you say zinc blend now, in diamond carbon atoms forms CCP, or you can say the FCC. So in diamond, the carbon atoms form CCP or FCC. In zinc blend is also like that, isn't it? Okay. And the carbon atoms are also present. And the carbon atoms are also present. Where do they present? They are present in, half of the tetrahedral void. Half of the tetrahedral void. Now, how do we come to know all these things? Students, as you all know, we have different, type of crystal structure, isn't it? You have rock salt type. Just I'm giving one, a quick revision on different types. You have rock salt type, or you have NaCl type. You have cesium chloride type. You have zinc blended type. Fluorite structure, anti-fluorite structure, isn't it? So if you can see rock salt type, it is a negative ion most of the time, forms a lattice. Only in fluorite structure, it is a cation which forms a lattice. Remember. Otherwise, negative ion will form the lattice, okay, and the cation will occupy the voids. So students, in rock salt or in NaCl type of crystalline lattice, Cl minus ion is forming the lattice and the Na plus is present in all the octahedral void. Coordination number is 6:6, isn't it? Similarly, cesium chloride means chloride ion is present in the BCC lattice, cesium is in the cubic void inside the body. Zinc blend means S2 minus is forming the lattice, that is a CCP lattice, and the Zn2 plus ion is occupied by half of the tetrahedral void. Only in fluoride, the positive ion is forming CCP and the negative ion is present in all tetrahedral void. Anti-fluoride means the negative ion is forming CCP and the positive ion is present in all the tetrahedral void. Now the diamond comes in this, diamond has zinc blend like a structure, isn't it? It has a zinc blend like structure. Therefore students, as I told you, diamond is made of only carbon. Therefore carbon is forming the CCP and carbon is present half of the tetrahedral void. Now when I say carbon atoms are forming the CCP or FCC, how many atoms are there in FCC? Totally 4. I hope you have done this calculation. 8 particles are at the corner and 6 particles are at the face. Therefore, total number is 4. Correct? So, there are 4 particles. Carbon atom is present in tetrahedral void. If the number of atoms are 4, how many tetrahedral voids are possible, student? How many tetrahedral voids are possible? The number of tetrahedral void will be 8. Correct? Double. Out of 8 voids, only half are occupied. That means only 4 tetrahedral voids are occupied. So total number of atoms are 8. 4 atoms are in the CCP lattice. Remaining 4 are present in the tetrahedral void. So answer is option D. So very good, students. Okay. So I can see some of you are answering, isn't it? Very good. I can see Sudhindra is answering very quickly. Good. So we'll go to the next one. Go to the next question. Kindly read the question. The number of octahedral void per atom present in a cubic closed packed structure is. The number of octahedral void per atom present in a cubic closed packed structure is. Option A is 1, option B is 3, option C is 2 and option D is 4. So you need to find out how many octahedral void is present per atom. Students, suppose if you think you have a lattice and the lattice has, you think, X number of atom, or the lattice is made of X number of atom. Then the number of octahedral void is equal to X, number of tetrahedral void is equal to 2X. Understood now? So here the question is asked, for one atom, how many octahedral void? I told you, if there is X number of atom, X number of octahedral voids are present. Therefore, for one atom, one octahedral void is present. So the answer should be option A. I hope I am making it clear. Suppose if you have 30 atoms are forming the lattice, then you have 30 octahedral void, you have 60 tetrahedral void. So for one atom, it is one void. That is what asked in the question. So answer is option A. Okay. So we'll go to the next question. Structure of a mixed oxide is cubic close packed. So a mixed oxide is given, which is having a CCP arrangement. The cubic unit cell of the mixed oxide is composed of oxide ions. So in this cubic unit cell, in this CCP, there is oxide ion. Okay, the oxide ion is forming the lattice, students. 1/4 of the tetrahedral voids are occupied by divalent metal A, and the octahedral voids are occupied by monovalent metal B. The formula of the oxide is. So students, you have a question on your screen. Kindly go through the question and try to find out the answer. Now it is said that the lattice is CCP. Now CCP is formed by oxide ions. So how many atoms are there in CCP, student? Number of atoms in CCP. How many atoms are there in CCP? For CCP, for FCC, number of atoms are 4, isn't it? For BCC, number of atoms is 2. For a simple cube, number of atoms is 1. So number of atoms in CCP is 4. We are aware of it, isn't it? Now, number of tetrahedral voids. we know that double the number is tetrahedral void. That means 8. It is said that 1/4 of the tetrahedral voids are occupied. 1/4 is occupied. By what? Divalent metal A. So, we are writing number of A2 plus ions. Does all the tetrahedral voids are occupied? No. Out of 8 tetrahedral void, only 1/4 is occupied. That means out of total 8 tetrahedral void, only 1/4 is filled. That means number of A2 plus ion is 2. Then octahedral voids are occupied by monovalent metal B. What will be the number of octahedral void, student? If the number of atom is 4, then the number of octahedral void is also equal to 4. And it is given that all the octahedral voids are occupied by the metal B. All the octahedral voids are occupied by the metal B. So students, this 4 will be also equal to number of B plus ion, isn't it? Because all these voids are filled by B plus means there are 4 voids. So naturally there will be 4 B plus ion, isn't it? Okay. Now we have the ratio now. We want the ratio between A2 plus, B plus and O2 minus. Now how many A2 plus are there? There are 2. How many B plus is there? There are 4, isn't it? There are 4. How many O2 minus is there? O2 minus is number of atoms which is forming the lattice, student. So this is nothing but O2 minus, isn't it? Number of O2 minus. So 4. That means 1 is to 2 is to 2. So formula will be A, B2, O2. So answer is option D. So have you understood, students? Is it clear? The answer is option D. So I hope it is clear, students. So we'll go to the next question. A solid compound XY has NaCl structure. If the radius of the cation is 100 picometer, the radius of the anion Y will be. Okay. So students, in this problem, radius of the cation is given and the radius of the anion is asked. Okay. Now from the last class I have been telling you, you should know the radius ratio rule, and it is said that it's a NaCl structure, and sodium chloride means it is octahedral, isn't it? So students, here the coordination number of sodium chloride is 6. Therefore its radius ratio is 0.414. I hope you can understand. It is 0.414. Sodium chloride has a coordination number 6. Each Na plus is surrounded by 6 chloride ion and each chloride ion is surrounded by 6 sodium ion. So its coordination number is 6. So its radius ratio is this range. So we are going to take the smaller range, 0.414. So you have the formula now. Radius ratio is equal to radius of the cation and radius of the anion. Now this radius ratio is equal to 0.414. Cation is given as 100. You have to find out the radius of the anion. So R minus is equal to 100 divided by 0.414. So how much you're going to get? So it will be 2 times. So your possible answer is A or C, isn't it? 2 times. So 2 times means almost you will have 8,000. So that will be answer can be option C, or else you can exactly find out, but it's very clear the answer will be option C, 241.5 picometer. So you have the radius of the anion as 241.5. Okay, go to the next question. AB crystallizes in BCC, body centered cubic lattice, with the edge length A equal to 387 picometer. The distance between two oppositely charged ions in the lattice is. So AB crystallizes in a BCC, body centered cubic. Okay. So AB crystallizes in a body centered cubic lattice with the edge length A equal to 387 picometer. So you have to find out the distance between oppositely charged ions. Alright. So students, look here. What is this? Soham Vyas, what exactly you are, okay. KCET strategy you are asking. Okay. So, you know, before maybe the next, next month we will have a discussion on that also. Okay. So now it's the time for us to, because we have little time, so for learning the topic, isn't it? So let us learn well, and then we will go through the what are the possible strategy we need to follow to face KCET 2022. So you will be given a right kind of information, Soham, at the right time. Okay. So we will have now the discussion. See, before anything, first you need to prepare yourself, very well for the topic. That is very essential. I have been telling you that you have to prepare very well, and then slowly other aspect also we need to see. So we will go for the next question. AB crystallizes. So I told you the edge length is given as A, isn't it? So the question is asked the distance between two oppositely charged ions in the lattice. So if you are taking BCC, if you have particles like this, the side, this edge is A. It is said that student, the edge length is equal to A. Now the question here is the distance between two oppositely charged ions. Now in case of student BCC, the distance between the oppositely charged ions will be root 3a by 2. Correct? So if you want to know, this is root 3a student, this is root 3a. The distance between the two oppositely charged ion is root 3a by 2, isn't it? So when we say root 3, you know the value as 1.73. A is given as 387 picometer divided by 2, isn't it? So this will be, almost, if I say 212923, see 193 into 1.73. So what can be the possible answer, student? What do you think the possible answer will be? It cannot be 200. It cannot be 250. It cannot be 300. It should be more than that. 193. 193 into 1.73. You multiply. Otherwise, it looks like the answer is option A, 335 picometer. So we'll go to the next one. Lithium metal crystallizes in a body-centered cubic crystal. If the length of the unit cell of lithium is 351 picometer, the atomic radius of lithium will be. So students, you know that when I say BCC, the radius is equal to root 3a by 4. This is a relation between radius and the edge length. Now this is root 3. A is given as 351 divided by 4, isn't it? So once again it will be 1.73 351 divided by 4. So how much it will be, students, if you are finding out? The answer will be almost 151, or I can say option A will be the right answer, isn't it? You are going to get option A as the right answer. Okay. So students, now for the time being I am stopping my class. See, related to the CET question, chemistry question, you can ask me, alright? Okay, whoever is the person related to the subject and related to the chemistry topic, you can ask me the question. So students, you will have my next YouTube session in the, on 11th, exactly at 2 o'clock. So we will be dealing with some of the important concept. I'm going to discuss some of the essential concept and also going to solve few questions. These are the concepts which are very much essential, student, for solving CET or for solving JEE or NEET or any other competitive level exam. So do not forget and do not fail to attend the next class. It is on 11th and exactly at 2 o'clock. Okay. So till then, so bye bye students and take care.